when you get this, the level will look something like this. Whatever I end up saving in this file will be here. And the way our game works, in a nutshell, before we look at the actual gravity code, it's very, very simple. We have a circle here, which is our player, and I'm going to turn on some debug features in just a minute so you can see things more clearly. And then we have circles and squares. Now the big circles and the big squares are the things that we jump on and we run around, and the little circle is our character. In fact, let me turn on the debug features. If you go into Common Lua, at the top there is a flag called Debug Enable. Set that to true. Reload the project. What you're going to get is it will show you everything that was there before, and the green object is the current attractor. It's the object that is our gravity source, in a sense. Whereas anything yellow is not attracting us. Furthermore, there's an arrow on our player that shows the direction that gravity is pointing. So at this point it's pointing down, but if I were to run around the character, now gravity is pointing sort of up and to the left. These little red numbers here tell us how far away the character is from that object. And the rule of thumb is, what we do is when we create the level, I put all of the attractors, all the possible attractors, which are these level bits, in a table. And then I, every frame, iterate over the table, and I say how far away is that object from the player. And then I store that distance right in a field on the object. And then when I get done with that, I sort the table based on nearest to furthest. And so the nearest object will always be the first entry in the table. The second nearest will be the next object in the table, and so on and so forth. Now the reason I did this was because although we're doing a simplified gravity model in which only one object is contributing our localized gravity, if I wanted to make this a much more complex and interesting example or start to change it into a different game, I could theoretically say the closest 3 objects all apply a force. And then we would get this much more interesting gravity situation where you're getting pulled by multiple objects and it could change the feel of the game. But in this case, the nearest object is our gravity source. And I'll get to what it means to be a gravity source in a minute. The only other thing that you need to know about this example right now is that the way movement works, okay, so we have a force that pushes our object in the direction of the red arrow, which is our gravity, our personal gravity. And then I'm utilizing, now I'm sure that this is not how they did this when they implemented the game, the original game, but it's my rule that I look at a game that I want to duplicate the mechanics of, and I say, what tools do I have in my toolbox that will make it easy for me to reproduce that mechanic? So in other words, I don't have to do it the way they did it. One, I don't know how they did it because I never saw their code. But I can guess. And so what I said was, I'm going to use physics to move my character and push it into other objects to have a personal gravity. And then I'm also going to use friction to do the movement. So what you don't see here is that when I push the left arrow, this character, this object here spins. And it has a high friction, and because it's in contact with this circle, which also has friction, that causes it to want to move in this direction. It actually pushes it. So it's spinning counterclockwise. And it's pushing on this static body here, and it simply pushes it around. So a force is pushing it into the object, and then another force, which is friction, is causing it to move around the object. So I cheated. I just used real basic, simple built-in feature of Box2D, which is used by Corona, to implement movement. And the only other thing I have left then to do is jumping. So when I click on this button.
So Ed, just for the imagination of the viewer, if you were envisioning a character with their feet on the bottom and their head at the top,
right?
Then their feet would always be planted to the object.
Right. We're going to replace this, all the stuff you're seeing in a future installment. with some artwork, but I wanted to first ground people in the concept of the direction in which the force is moving, the distance, the objects, who is my attractor, the green object, so they understand where we're starting from.
Okay, cool. Yeah, I just want to get the thoughts on that.
Get to the point where there's a little character with its feet, and it's going to have an animation running and jumping and stuff like that. It'll be cool and fun, and people will learn stuff from it.
Well,
the way I implement the jump is a impulse. So there's two kinds of basic forces in Corona. There is a force, which is a general force in a direction, and I'm talking about linear forces at this point. It basically a force that pushes on an object in a linear direction, which is what's keeping our white object pressed into the green object. But when I want to jump, I want to go in the opposite direction of the arrow. So what I do is I simply figure out the direction of my current gravity, and then I apply an instantaneous force, which is called an impulse in Corona. And I just apply a slight impulse, and then what it does is it gives like the player instantaneous momentum change in the opposite direction. It kicks it basically, or smacks it like a cue ball. Now, when you play around with this demo, the one that's coming out of today's Hangout, you're going to notice some issues. Issue number one, let me see if I can do it here. This has no concept of being on the ground, so I can jump, 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 jump. I can keep jumping, which is fine and cool and fun. In fact, I think people will go, hey, that's pretty cool. But the problem that would make this more fun is this has no what I call air control. Actually, it's a common phrase. So air control is what it means is when a character, like in a platforming game, is no longer on the platform, and you know how you can like move left and right while you're in the air? That's air control, the ability to continually adjust your character's position even though it's not touching anything. And so I have not implemented air control yet, and the reason is to implement air control correctly, I have to be able to detect when I'm touching something or not touching something, i.e. on a platform or not. And that code is simple, and the concept behind it is simple, but it would have obfuscated, made this current today, the gravity discussion more complex. So we will talk about a concept which is called a foot, where you give the object a sensor that can detect when it's touching something or on a platform. And we'll talk about how you implement air control in a radial situation like this when you're going around an object. Okay, so I've talked a lot, haven't looked at any really interesting code, and I'm just going to jump right into the gravity and explain how it works.
Although I will say I'm very excited about downloading this and playing with it, just for the sheer fact that when you made the character jump, the camera tracked the player momentarily until they came back to the shape, you know. So there's a lot of things going on there that I'm like, oh, I'm gonna dig into that and see what you're doing there.
Well, 99% of what you just saw going on can be found in the file that we're looking at now, which is
Sweet.
Player Lua. It's the builder for the player object. And the one bit of code that we're going to look at, let me find it, is, it's taking me a minute, I apologize. Here it is. Okay, so there's two functions that we use to calculate gravity, or to do this gravity business. The first of them is a function called calculate gravity, which is called, let me find it, which is called every frame. So I'm not going to go through this code right yet, but the player has a enter frame listener on it. In other words, that function executes every frame. Every time the next frame starts, it executes, and it gets to make some decisions, change the position of the character, etc., etc. And among those things it does is it calculates a distance to all of the pieces. So it says, white character, how far away are you from this, from this, from this, from this, etc., all these little blocks, and it sorts that table. So that's what the first function here, calculate distance to pieces, does. And then the next function says, all right, having now figured out the closest piece, let's calculate a gravity for the player. So let's look at calculate distances first.